Yeah, so my name is Dan. I am known as Nadako online. Maybe someone heard about me. And I am one of those programmers that still believe that others, and me included, are not monkeys that smash rocks, and are kind of interested in fancy technology stuff. So my talk will be a bit technical. Yeah. So everyone already knows that Hex has this static type system and compiles to basically anything. And yeah, but static typing is kind of a broad term because there's a lot of other languages that provides static type checking and all that stuff. So here I would like to talk about a couple of neat tricks possible with type system of Hex specifically, and one of them are abstracts. Yeah, I'm going to show some code, but let's talk about abstracts a bit. So as the most type systems out there, Hex provides, Hex's type system also provides basic types like numbers and bools, and structured types like classes or anonymous structures, all that stuff. And these are what programs basically operate on at runtime. Of course, if we don't want to go into deeper levels and where everything is basically words and bytes. So yeah, and yeah. But besides that, Hex also provides this concept of abstract types, which allows for giving a completely new meaning for any type that already exists, but only at compile time. And what this basically means is that we can have high-level abstractions, type-safe abstractions, without making the runtime code larger and heavier, because the abstractions exist only at compile time. So yeah, one cool idea is to distinguish values of basic types that have different meaning, like they are different types. For example, in a multi-language UI, we typically don't hard code messages, right? But instead we use locale keys to get the actual translated message from some kind of translation catalog. And naturally we use the string type for these locale keys. But that means that compiler can't really distinguish the locale keys from any other string and the translated string as well. And at least in my experience, this often leads to problems with people that use the untranslated key for display or pass an already translated string for translation again, because they are both strings and compiler can't prevent that from happening. But with Hex abstracts, we can actually solve this by introducing a separate type for locale keys that will protect us from these mistakes. I prepared some code to show you. Here, locale keys, yes. But okay, let's try to build it. Yeah, okay. Yes, of course. Okay, I need to close all this stuff. Is that good enough? Yeah, so let's read this code a bit. So at the top we have a definition of abstract type over, it's called locale key, and it's defined over the string. That means that the actual runtime type will be string, but at compile time this is a locale key. And we provide two functions. One of them is a constructor to create the instances of this type, and another one is just a helper function that just returns the underlying string value that we will use later. And then we have this class with a static inline field of this locale key with the value hello, just so we can access this locale key from anywhere. And then we have our entry point class with the main function and two functions that actually do stuff. One of them is translate, which takes the key and returns a string. And the super nice implementation for the localizations for us is just like returning an uppercase version of the key that will work for us. And another function is a display function that takes a string, a translated string, and just traces it. But it could be like inner HTML something. It doesn't really matter. And the entry point main function shows how to use this. So we call the translate function, pass our locale key that we created here, and then we get, so this is locale key, as you can see, and from that we get just a string, and then we can pass the translated message to a display function. It's super nice. Let's take a look at the generated JavaScript code. Yes. So yeah, this is the code that Hex generates from that. We have this translate function, which takes the key, but as you can see, it actually treats it directly as a string. There's no code for this type that is called locale key. So because, as I said, the values of this type will be strings at runtime. And then there is a display function that just do the console log. Also, it works with strings, as we said. And then we have this translate function call, which gets the already inlined hello string that we passed here. So it's nicely inlined, and so we get the translated message to display. So nothing really, no overhead, basically. That's the point that I want to show with the this generated JS file. But the benefit from that is actually the compiler now treats these two types of strings differently. And it knows that locale key is not a simple string, and a simple string is not a locale key. So if we, for example, try to translate an already translated message, we get a compile error that says string should be locale key, which is exactly what is the problem. So we are kind of guarded against that. And vice versa. If we try to display a untranslated locale key, we will also get an error saying locale key should be string, because it's not really a string, even if it's a string at runtime. At compile time, it's not. So yeah. This is one of the nice applications of abstracts. Another nice idea would be to provide different types for any kinds of IDs for things, for example. And another application for this idea is having parameterized abstract types. And I'm gonna show something to you. Let me, yeah, as most of the types in Hex type system, Hex abstracts can be also parameterized. This is also known as generics, so they have type parameters. And that means that we can attach additional type information to specific instances of an abstract type. And for example, let's take a look at Node.js event emitter class. I have it here in the Scratchpad. This is the super simple definition for the Node.js event emitter or npm EE something module. And it has this on method that takes an event name as a string and some function as a listener. This is pretty good, but it's not really safe, because first we can easily make a typo in the event name, and the second is that the listener function signature is not checked at all. It says just a function. But we can actually improve this with parameterized abstracts. So let's switch to another project that I prepared and take a look at this. Yeah. So here we define a type called event name. It's an abstract type with a real type of string, obviously. And it has this type parameter named t. So we can actually create different instances of this type, supplying different type parameters. And then we use that for our modified event emitter class. So our on function is also now parameterized. It takes an event name not as a string now, but our special type event name with the same t. And the listener is actually of type t. So whatever is provided in the event name should be also should have the same type as the listener, and that will be compiled type checked. So let's see at the actual entry point code. So first we define this my event instance, which is an instance of our abstract type event name. We pass this string to the constructor, which will become its value basically. And this is the function type that defines the type of the listener. This is the syntax, the new syntax of Hex for a function that takes two arguments, int and string, and returns a void. And then we use it. So here in the main function, we basically create an instance of event emitter, and then we call this on function, passing the my event there. And already from that, we already know that, the compiler already knows that the function has two arguments, and one of them is int, as you can see here, and another one is string. So we don't really even need to write any types because it's already type safe. But if we will make a mistake of some kind, for example, we explicitly change the type to something that is not conforming to the requirement, like bool instead of integer for the function type, Hex compiler will immediately complain about that, and it will say that int should be bool, which is actually vice versa. So this is an issue, a little bit of an issue with the current compiler version. Yeah, sorry about that, but the point is you still get the compile time error, which is really, really nice. And the same happens if you, for example, specify more arguments or any different value for this. With the case of more arguments, it will complain about the whole function type again, that A, B, and C should be this function type instead. So yeah, we are pretty safe here with the type of our events. Yeah, that's pretty cool, I think. But now let's change the topic, change the subject actually, and talk about macros, because this is another killer feature of the language. So macros is the name for a set of code generation features in Hex, actually. And because of macros, static typing is even more useful in a language like Hex, because we can make it works for more than a simple type checking. Yeah, I prepared one showcase for that, which is data validation. So combining these proper type declarations, as we did before, and we'll do more, and code generation can actually save us a great amount of boilerplate while still improving the code safety. So let's talk about that data validation a bit. Sorry. A lot of programs nowadays are actually data-driven, especially games when there's a ton of numbers and texts that are provided by designers. And since this kind of data come from people, and people tend to make mistakes, and tools that we make for people are often really far from perfect, it's almost always a good idea to validate that data. And one of the most popular solution for that currently is JSON schema, I think. But I would dare to say that with hacks, you actually don't really need that, because you have a much more powerful and ultimately a more simple solution. Because to get the type safety for our code, we anyway describe all our types in code. So why don't we just reuse the type definitions to get the type safety for our data as well? Let's take a look at my other example. Yeah, validation. What? Sorry. Anyway, yeah. So here we define a type def, which is just a name for a structure that has a string field name, an optional int field age, and also a field cart, which is like shopping cart, which is an array of product ID. An array of product ID is an abstract over int, because that's what I was talking about in the first part. It's pretty nice to actually have meaningful types for meaningful things, and not just super basic integer things. Anyway, then we declare this type, and then we call validation here. So first we parse some JSON data that may or may not conform to the type, and then we call this magic validate function that I wrote that takes the raw data, the type that we want to validate against, and it returns the validated value, which is typed as our type, and we can access it properly, like customer.name. The compiler knows that it's a string, so it's properly typed, because at this point it's just unknown type, dynamic basically. And an interesting thing here is what is actually generated in JavaScript here. But first let's take a look at the validate function, because this is actually a macro function. I won't go into too much details here. It's super dirty. It was written by me in about half an hour, but it's around, I would say, 70 lines maybe. Yeah, if you don't count the imports. And what it basically does, it takes the type that we pass to it and checks if it's a string, and then it generates the code to check if the value is string, and same for int, same for anonymous object types and arrays and all that stuff. It's not really relevant, because what is interesting is the generated code here. So yeah, this generated code is a bit bigger, because all the type checks that require some utility code. But let's take a look at the generated main function. So we have this raw data variable, which is the result of JSON parse, And then instead of the validate call, we have quite a ton of code generated in JavaScript. And that actually does the validation of the dynamic value. Like if this is not an object, then throw an error. If the object has a property age, because it's optional, then also check if it's an int, then throw an error. And same for our card field. If it's not present in the object, then throw an error because it's required. And then we check if it's an array, and then we iterate over that array, and we check every element that it should be an int, because that's how I'm implemented in the macro. It checks that the real type is int, so the dynamic value should be also conforming to int, and it does the same for name. And this is pretty good because we didn't have to actually write any extra schema or handwritten boilerplate code to validate values. It's all auto-generated. And then if we, for example, want to add some new things, like, for example, let's add a wish list to our customer. Which is also an array of product ID. Let's build it. It gives us an error right away because I don't just build it but also run it, and it already complains that the data, if I can scroll it correctly, it already complains that the object doesn't have a field wish list because it's not here. But anyway, let's take a look at the generated code again a bit. So we got this new block of code that does pretty much the same as it did for card. It checks that the field is present, that it's an array, and the elements are int. And another cool thing here is one of those that I implemented in this demo macro is actually that you can reuse these custom abstract types to add some custom validations. For example, let's imagine that we have some database of our products and thus a limited set of product IDs, and we want to validate for that. And we can actually really easily do that. So I made the macro check for the validate method. I will quickly show it to you. Validator. Yeah. So if I manage to handle all this white space. Yeah, so if we get an abstract, then we find the field validate. If it's there, then we add a call for that. So that should work, and let's try if it actually works. I have some code actually prepared for that, so I don't make any stupid mistakes and typos. So I'm gonna just copy paste it here. Let's close it for now. So this is our database. It's an array of possible product IDs, and this is the method that our macro will look for to actually add some more validation. Yeah, it still fails because we still have no wish list, so let's make this optional. The code is still generated, so let's take a look at it. Yeah. So now we, in addition to the check for int, we also have these checks, these validate calls for every element of our array in card, as you can see here, and the same we do for wish list. So we didn't have to really add any field specific validations. And this simple macro is actually pretty smart, because let's as the final note, let's make our wish list structure a bit more complex and see if our macro can handle that. So now the wish list is actually an array of objects with ID and priority. And the ID is still a product ID and priority is just int. Let's rebuild that and see what will be generated. Yeah, this is a really small screen. Yeah, so here is our wish list. It's now optional, so we only have this this validation in a branch if we have a field called wish list. We still check if it's there. We still check that it's an array, and for each element now we do a much more checks because it's now an object and it should have a field ID, and that ID should be a number, and the number should be validated against our validate function, and then it also adds the checks for priority. So I think this is pretty cool. This is a nice application for macros. And it's super nice that you don't really need any other tools than your compiler. This is basically what Uri was talking about when he was talking about this language-oriented programming, right? So you can teach your compiler to do pretty nice stuff. So, okay, let's wrap up, I guess. Both abstracts and macros are huge topics, really, and there are a lot of more features and applications to explore and talk about. And it's my point here is that knowing how to use this stuff can really make your workflow really safer and more lightweight, both in the source code and at generated runtime code. So, yeah. Finally, I collected just a list of links to some nice macro usages that I find really awesome. Most of them are made by Uri and Nicola, actually, because they are our macro experts. This HIPS engine has two really nice cases of macro application. One of them is DSL, domain-specific language, for shaders, actually. So you can write shaders in hex syntax and make it compile to whatever platform. And shaders, if you don't know, is a program for GPU, actually, that we use for games. And another one is HXD-res, which is a name of package in the HIPS library. And that thing actually provides a statically typed access to all the assets that you use, and you can access your assets as just fields. And if it's a, for example, JPEG file, it will show up in your autocompletion as an image, and you can work with it as an image. That's pretty cool. Another one also by Nicola is a macro library called HXBit. It generates all the code similar to my demo, but for serialization and network synchronization, it's super nice. Another thing is Castle, which is a static database, which goes a different way, actually. It generates hex types for hex compilers from external JSON definitions. I'm not sure if this is the right way, but that works for Nicola, and it's pretty nice to actually learn. All the Tink stuff, basically, but specifically I like Tink JSON, which is a parser generator for JSONs based on types. which does parsing and validation at the same time. It's pretty nice. Also Think SQL, which provides type-safe DSL for doing SQL requests, and Think Template, which is a template language that actually is processed by macro and is compiled to code at the compile time just by hex, which is super nice. And the more simpler one to just get a hang of macros is Simon's HXArgs, which is a library that does the command line argument parsing by the very simple declarative syntax, and it generates a ton of code to actually parse the command line and check if the arguments of are of valid types and stuff like that. And also my 2 experiments that you can check out if you wish. One of them is type-safe localization access. I have a README there. And another one is, I didn't really even document that, but that is basically a thing similar to Google Dagger, if you know. That is a dependency injection framework that has no reflection at all, and it completely works at compile time. This is not like a really useful library because I never really worked on that because I don't use dependency injection libraries, but as an experiment and as something small for learning macros, this might be interesting. Yeah, that's it for me. Sorry if it took so long.